Okay, so in this video, or what I'm going to show you in class today, is how to complete the LAndslide Lab. And I'm going to show you where it is in case you're looking at this video later. So it's in Unit 2, Week 4, where it says landslides. And there are two documents here. The first document, if you open that one up, will take you to the lab report that you have to submit. And then the second document, so I'm going to go back to the Week 4 folder, is the landslide prevention activity. That's the Google Slides that you use to build a house and create materials for the house that will, or buy materials for the house that will prevent the house from falling down to a landslide. So remember, there's grass, trees, etc. Okay, so let's go ahead and begin with going over the lab itself. All the instructions are there, so what's really important is whenever you're trying to do something is to read the instructions first. If you're not sure what's going on, it's probably because you didn't read the instructions. If after reading the instructions you still have questions, then please reach out. So the purpose of this lab is for you to find a way to prevent your house from sliding down in a landslide. And in part one, you're brainstorming how to do that. But first, you're going to learn what a landslide is, causes of landslides, why are they destructive, and what can you do to prevent a landslide. Now, we went over this whole class, so you may have this done. Great. If you do not have it done, then you're going to open up this link, which will take you to the slides for that day. And if you scroll, okay. Here we start talking about weathering and erosion. You can just keep going, and then bam, slide 9 starts on landslides. So you can watch this video, which will give you an example of what a landslide looks like, and then read through the slides here. There's another video which will show you how to prevent landslide. And then for the real meat and potatoes, so this is a part you definitely need to look at. Starting on slide 15, this is where you're going to find the information to answer those questions, okay? So you go through those slides there, 15 through 26, slides 15 through 26. Okay, so that will help you with part 1. Any questions? Go ahead and put those in the chat if you have questions. If not, we're going to move on to part 2. Okay, looks like we have no questions. All right, so for part 2 is practicing using kinetic and potential energy equations. So here you have a house. It's at the top of the hill, so it's on A, it's at the top of the hill, and then it starts to slide down because of a landslide. So what you're doing is you're calculating the potential and kinetic energy of the house at part A, B, and C using the information in the table here. So notice for A, it gives you the mass of the house, the height, and the speed. All right, so to calculate the potential energy for A, what you need is the mass, G, which is 9.8, and the height. So the potential energy here is going to equal to the mass, this number here, $35,000, times G, which is 9.8, and then times the height, which is 12 meters. Okay. So for that, you need to calculate it, you're going to multiply those numbers together. So 35,000 times 9.8 times 12 gives you this very big number. This is 4,116,000 joules. All right, so you do the math and you calculate it. Okay. Just a quick reminder here, G is equal to 9.8. So when you see G, that's equal to 9.8. All right, you have to do the same thing for B. Calculate the potential energy of B. Again, using the same process. So for B, it's the mass, which again is 35. The mass doesn't change for the house, so it's 35. What do I put for G? Put it in the chat, please. What's the value for G? Says it right here. G is always equal to no one? You're doing the last one on your own. So if you think that, so this one's C, everyone's supposed to do that one on their own. So you should know that G is equal to 9.8. Now, some people aren't following along, so I understand that. But for those of you who are following along, you should know G is equal to 9.8. All right, and then the height. Now, at part B, so if we go back to our house, A, the house was at 12 meters. And for part B, it's at 10 meters. Okay, and how do we get the height of the house? We look at the middle of the house. So here's the middle of the house, and we go over to the, actually this is the base of the house. We go over and we find the height at part A. So here's the bottom, we go over, and that's 12. But for B, when the house is tilted, we use the middle. So that's 10 meters is the height for B. All right, so with that being said, we go ahead and we put in 10 meters there. And then we multiply those numbers. And they gave it to you for this one, but you'll have to do it in your lab. All right, so I'm not going to calculate that. You're going to calculate that. So finish the calculation. All right, so that's how you do the potential energy. You're going to have to do the potential energy for this one as well. So make sure you get the numbers in. For kinetic energy, you use this equation, 1/2 times the mass times velocity squared, which is the same as saying 0.5 times mass times velocity times velocity. So for the kinetic energy, we're going to start with 0.5. We're going to multiply it by the mass, which again is the same, doesn't change because the house is the same house, 35,000. And the velocity here, or the speed, is 0. So we're going to do 0 times 0. Now this math is pretty easy because anything multiplied by 0 is just 0. So the kinetic energy here is 0 joules. And that makes sense because at part A, the house is not moving, it's standing still. And we know kinetic energy is the energy of movement. So if the house is not moving, it doesn't have any kinetic energy. Now let's calculate it for the house at part B. I'm not going to do the math. You're going to do the math for that. But, so it's kinetic energy. Again, it's going to be 0.5 times the mass. So again, that's the same. Times the velocity or speed squared. And here the speed, so remember you got to look over here to find the speed. So that's 9 meters per second. That's 9 times 9, okay? So now what you're going to need to do is you're going to need to do this calculation. In your calculator, you're going to multiply these these 4 numbers, sorry. Once you've done that, you have to do it for C as well. So the kinetic energy, you're going to use the numbers in this part of the chart, so in column C, to calculate the kinetic energy. All right. Are there any questions on about the table? And so Trinity, I unsubmitted your, just so you know, I unsubmitted yours because you need to do this part here. So that's the part you need to do. So if I unsubmitted your work, you want to check and see what it is you're missing. So there should be your math should look like this, and you should have a value for potential, and your math here should be the same that you see here, just different numbers. And again, you need to have a value for kinetic energy. Okay, once you've done that, you're going to use the information in your table to answer questions 2, 3, and 4. The thing to remember here is that at the top of the hill, the house has the maximum potential energy because it's at the highest height. And it has the lowest kinetic energy because it's not moving. Its kinetic energy is 0. As the house moves down the hill, the potential energy is transferred into kinetic energy. So when that happens, the potential energy goes down and the kinetic energy increases. And it's here at the bottom at part C where it's going to have the most kinetic energy. So that will help you with questions 2 through 3 and 4. Okay, now we're going to go into part 3. So for part 3, you're going to need to have this open. Okay, you're going to need to have that open. So you can go ahead and I'll give you guys a few seconds to get that open. Remember, that is the landslide prevention activity, this one here. Okay, so if we go into the folder, it'll be the second one. Okay, so get this document open. All right, so for this section you're going to plan how to protect your house from a landslide by using either grass, trees, rocks, a mesh net, a retaining wall, or sandbags. Now, each of these things cost money, and you cannot spend more than what you have, and you have $5,000 to spend, so you only have $5,000 to spend. All right, but you can choose whatever you want as long as you don't go over the 5,000. So first thing we're going to do is we are going to choose a house. So let's say I want to use this house. I'm going to click on it and I'll do Control C. And then I'm going to move to my hill, Control V. And I'm going to put it at the top of the hill. All right, so here's my house. Now it's time for me to start spending my $5,000 on what I want. So I can spend it on grass. That costs $3,000. So if I use grass, then I will only have $2,000 left. I can spend it on trees. Each tree costs $100. Rocks, I could spend it on that. Each rock costs $100. So like when you grab one of these, that's $100. Each sandbag is $200, the net is $2,000, and the retaining wall is $3,000. So clearly I can't get a retaining wall, a net, and some rocks because I'm going to go over my budget. So I'm going to choose grass because I think grass looks nice. So I'm going to do Control C, and then I'm going to do Control V. And when I do that, it covers the house. So I can change that by just clicking on the house and doing Control X and Control V. So I cut it out and then I repasted it. All right, so now I've got my house. It looks good. All right. And I've used $3,000. So in my budget now, so this is the part that's important, I used some grass. So I'm going to put 1 here. And I'm going to multiply the amount by the cost. So 1 times 3,000 means the total I've spent so far is $3,000. Oops. Okay. I want to put some rocks and trees on. I think those are the things I want to use. So I have $2,000 left, so I can get some rocks and trees there. I have enough money to get some. So I go back here, and let's say, for example, I want to get, I like this pine tree, and I like this tree with flowers on it. So I'm going to click on it, hold down the shift, click on that, hold down the, click and hold down the control is what I should do. And I want an apple tree. Click, hold down the control. And then I'm going to do Control C. These are the trees I want. I'm going to go back to my house. And I'm going to plant them. Okay, so I can move them around. Take this one. I want it here. Apple tree, I want it by the front of my house. And I want some more of these. Maybe I'll get a couple more pine trees. I really like pine trees. So I've used 2 of those. And I'll have another one of these trees. All right, so far I've used 1, 2, 3, 4, 5 trees. So in my budget, I'm going to do 5. I use 5 of them. So 100 times 5 will give me $500. Is how much I've spent on trees. All right, so I have now $1,500 left. I'm going to use some of that for rocks. So let's see. I like some rocks. I'm going to go back to my landscape here. I'll do Control C. And then I'm going to put some Control V. Oops, I did the wrong thing. That's not what I want to do. Let's try that again. I got to click on that, Control C, and Control V. Great. I have a rock here. I'm going to do a few more. 1, 2, 3. Let's do 4 rocks. So I've used 4 rocks. That's 1, 2, 3, 4. So in my budget, it's 4 rocks. So that's 100 times 4. That's 400. Okay, I think that's all I want to spend. I didn't use the full 5,000. Let's see how much I've actually used. So if I add together 3,000 plus 500 plus 400, it gives me a total of 3,900 or 3,900. So you want to make sure you get that budget done. Okay. After you've done that, the next part is to do a summary or reflection. So here you're going to calculate the maximum potential energy of your house. All right. Now remember, potential energy is equal to mass times G, which is 9.8 times the height. So we need to get the mass of our house. So to get the mass of your house, you're going to look at go back to the slides, and the house I chose, I used this house here, has a mass of 65,000 kilograms. So the mass of my house is 65,000. And G is always equal to 9.8. And then finally, I need my height. So to get the height, I'm going to look at where my house is here. So this one is about 12, I think. I'm using the numbers on the side here. Oh, where is my thing? And I'm just going to multiply these numbers together to get my potential energy. So for my house, I would multiply these numbers together. So my potential energy is going to be 65,000 times 9.8 times 12. All right, and I'll do the math. I'll calculate that out, multiply, and get the answer. Okay, the last few questions. Oh, sorry, question 2, you're asked to calculate the kinetic energy of your house. And it's the kinetic energy if your house is sliding at a speed of 12 meters per second. So for this one, you're going to use the equation kinetic energy is equal to 0.5 times the mass times the velocity squared. I'm going to color code this so you can see it. This is going to be your velocity. So in here, you're going to plug in 12. And your mass you're going to get that from the slides. Okay, So once you have that, you can go ahead and plug that information in, and you're good there. All right, and then the last questions are sort of reflecting on your landslide prevention. So which items did you choose to protect your house, and how will these items protect your house? So for that, you go back here. I use trees, I use grass, I use rocks. To discover how they will protect my house, if you go back to the slides at the top, these same slides, which I'll just reopen. For each of the items, grass, rocks, etc., it tells you how those items protect. So here, for example, vegetation like grass, plant roots hold soil together and absorbs water, which stabilizes the soil. So you can write something like this in your own words. For rocks, again, it says it stabilizes the soil and can improve drainage. Okay, so you would write this in your own words to explain how those items protect your house. All right, final questions at the bottom here. How did the budget impact your design? So did you wish you had more money, or did you have enough? And then at the bottom, thinking about how places like California and Florida, which are prone to landslides, discuss the natural habits that occur in those locations that can cause landslides, and what might need to be done. So for this part, natural hazards, once again, you're going to go back to the slides because all that information is in here. It talks about causes of landslides. So when you read what causes them, like floods, storms, earthquakes, wildfires, volcanic eruptions, etc. If you choose Florida, for example, does Florida have floods? Does it have storms? Does it have earthquakes? Like, what happens in Florida that can trigger a landslide? If you choose California, you think of the same thing. What happens in California that can trigger a landslide? You don't have to talk about both of them, just one. All right, any final questions here?